Welcome to Learn Yourself. Today we are going to learn and understand about soaps and detergent. This is under CBSE Std-10 syllabus. Before going into the details that how soaps and detergents will clean the clothes, let us understand the soap molecule. What makes this molecule perfect that it will interact with water also and it will interact with oil also, because we know that oil and water both are immiscible solvents. That means they cannot mix with each other. That's why they are known as immiscible liquids. But here soap molecule will interact with water also and oil also. And combinedly this soap molecule will create emulsion into a water. So let us understand that how the soap molecule is doing that. First of all, dirt is oily into the nature. Whatever dirt is stick on the clothes are oily into the nature. Now the soap molecule. The soap molecule are sodium or potassium salt of long chain carboxylic acid. These molecules have sodium or potassium salt and it has a long chain carboxylic acid. Now one end is ionic and other end is carbon chain. So if I am drawing a soap molecule something like this, that at this end, which is ionic, it has a sodium or potassium salt. This end is ionic and the other end, it has a long chain of carboxylic acid. So this is a long carbon chain which has a carboxylic acid at the end. So this is the structure of soap molecule. Now one end is ionic, that is along with the potassium and sodium salt. Other end is carbon chain, this. Now ionic end, it will interact with water because this end is made up of ions. Ions do dissolve in water, so they will interact with the water. Whereas this carbon chain, it will interact with the oil, because we know that carbon compounds belong to hydrocarbons, and hydrocarbons are not miscible with the water. They mixed and they will interact with the oil because their nature is completely different from the water. So now this is our structure of the soap molecule, which is perfect and which will interact with water also and it will interact with oil also. So combinedly it will form emulsion when it will go into the water. Now what is the meaning of emulsion is, when this soap molecule will go into a water, this is our water. So this ionic end will remain dissolved into a water, whereas the carbon chain which is interacting with the oil, it will remain outside. So the structure will remain something like this, that this belongs to the carbon chain and this is our ionic end. Ionic end will remain dissolved into a water and carbon chain will comes out. So combinedly these molecules will form emulsion, so that oil will also seems like that oil has dissolved into a water. What is the meaning of emulsion is, we have seen many of the cough syrup which has oily droplets, or many of the antibiotics which has oily droplets within them, but then also they will remain dissolved into a syrup, they will remain dissolved into a water. So they are known as emulsion based drug. So that is the same thing happening over here. They are creating emulsion. Emulsion means two immiscible liquids will mixed with each other so that they are making emulsion. Even our wall paints are based on emulsion because they have a part of oil into that and then also they will remain dissolved into a liquid. So that's why emulsion is two immiscible liquids will interact with each other and they will mixed with each other. So something like that will form when we are dissolving soap into a water. What is the purpose of this molecule is, if clothes have a water soluble impurity or it has a oil soluble impurity, both the types of impurity can be extracted through this structure, because we never know that what kind of impurities or dirt is there along with the clothes. So we require a molecule which will interact with both the things, that water also and oil also. So this is a perfect molecule which will interact with water also and oil also. So both the type of impurity it will extract from the clothes. Now let us get into a detail and see that how this molecule will actually work on the clothes. So now let us understand that when soap molecules are coming in contact with dirt which has oily nature, how they are extracting that from the clothes. So this is a surface of cloth. This is our cloth and this is a dirt molecule. Now dirt molecule has oily nature, and because of that this soap molecules will come and attach to that. But this is a soap molecule which has two separate different end. That is, one is hydrophobic end, other one is hydrophilic end. Hydrophilic end means that is ionic end, and it is interacting with the water which will remain dissolved into a water. So that's why it is hydrophilic end. Whereas this end is hydrophobic end. So phobic means it will stay away from that. So it is hydro means water. Hydrophobic means it will stay away from water. So that is hydrophobic end, and that is a carbon chain end which has oily nature, which will attach to a dirt and which will interact with the oily surface. So this is hydrophobic end, whereas this is hydrophilic end. If we want to know the same structure in this molecule, then this is oily end or this is carbon chain end, whereas this is ionic end which will interact with the water. And the same molecule we have shown it here in different representation. That black end which will interact with the water, and white end or transparent end will interact with the oil. Now here this is a dirt particle. This soap molecules will extract it from the clothes. So this end which is interacting with the oil and which has a carbon chain along with them, they will attach to the dirt. And so at first stage they will just attach with the dirt molecule, and slowly as the process will progress, they will take the dirt molecule within themselves and they will make something like this formation. This formation is known as micelle formation. Micelles means something like this, whereas in between the dirt particle is there, and around the dirt particle all these soap molecules are there. Now these soap molecules are attached to this dirt particle with the hydrophobic end, whereas other end which has a sodium or potassium salt which has an ionic end and which is interacting with the water, that end will remain apart from this dirt molecule. So simply they will cover the dirt particle inside themselves and they will cover the dirt particle within this micelles formation. So when this kind of formation the soap molecule will make, they are trapping the dirt particle within their molecules. So after this dirt particle will not detach from the soap, and once we will wash the clothes along with the water, this will go along with the water and it will detach from the clothes. As you can see it here, this soap molecules have completely covered the dirt particle and it has detached from the cloth surface. So once they will completely trap the dirt particle will get separated from the cloth surface, and after that it will go along or washed away along with the water. So this is the action of the soap. Now let us see the theory. Now let us understand the theory behind it. That when soap is at the surface of the water, the other end, that means the hydrophobic end will not soluble and it will protruding out of the water. Now the meaning of protruding is it is projecting out or it is coming out, because one end has oily nature and one end is soluble into a water. So ionic end which has solubility into a water, that will remain inside the water, whereas this chain will coming out from the water. The cluster of molecules. Cluster means a group of molecules in which hydrophobic end will be at the interior of the cluster and hydrophilic end will be at the surface of the cluster. This is a formation of micelles. So here I have shown the formation of the micelle, whereas this is a carbon chain which is interacting with the oil, so it will remain inside or interior of the micelle, whereas this end which is hydrophilic in nature, which is interacting with the water and it has ions on top of that, either sodium or potassium, that will remain outside of the cluster. So interior of the cluster, the hydrophobic end, and exterior of the cluster, the hydrophilic end, which is interacting with the water. So this kind of formation the soap molecules will form, and this cluster of molecule is known as micelles. Micelles collects the dirt and it will remain in the solution as a colloid. Once they are trapping the dirt particle will remain within this micelle formation and they will make colloids. Now colloids are a solution which are heterogeneous in nature, but it will appear as homogeneous because those particles are big enough to scatter a light. Two ends will not come together because ion-ion repulsion. Now after this micelle formation, these two ends that both are having either sodium ion or potassium ion, they cannot come together because positive ion repulsion will happen because both are having positive charge on that. So they cannot come together. So that's why they will remain in this pattern only because of ion-ion repulsion. They will easily rinsed away. Once this kind of formation will happen, they will trap the dirt inside them, inside the cluster of the molecule. Once we are rinsing it with the water, then it will go away with the water. Micelles are large enough to scatter a light because they are colloids, and hence the soap solution appears cloudy because they are colloidal type of solutions. So this was the information about micelle, and this was the soap cleaning action. Now sometimes the soaps are not giving us proper action. So let us see that what all are the reasons behind that. Into the hard water there are salts of calcium and magnesium. So when we are using soap along with the hard water, so this calcium and magnesium salts will interfere into soap action. They are forming some insoluble precipitate, and because of that we need to use more soap. So to overcome this problem we can use detergents which will not interact with calcium and magnesium salts and will give us proper cleaning action. So the hard water has calcium and magnesium salts. When we are using soap along with the hard water, they will form insoluble substance with the soap, so we need to use more soap. To overcome this problem, we can use detergents. Now what are the detergents? Detergents are sodium salts of sulfonic acid or ammonium salt. So they have charged end. We have already seen in micelle formation that how they are having a charged end, and at the end of the micelle formation the potassium salt or sodium salt will be there. So those charged end of these molecules will not form any kind of insoluble precipitate. So they will give us proper cleaning action with less detergent. Whereas if we are using the soap along with the hard water, then we have to use probably more soap and it will be waste of soap. So to use a detergent is a wise choice. So hope this video has cleared your doubt. In coming segment we are going to discuss many more important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.